what are the different ways a line and a plane can intersect in 3D? Let's start off by just sketching a plane, a 3D plane. I'm just going to draw a portion of it that looks rectangular. What are the ways a line can interact with this? Well, the most obvious way should be that the line can go directly through the plane. Right? So if the line touches the plane here, and then I'll do it as a dotted line to show that it's going behind. So the line can go right through the plane, in which case we have a point of intersection between the line and the plane. And yeah, that's the answer here. So this has one solution, one point of intersection, which is that point. So we can find a solution to a problem like this, which will just be x, y, z, which will be that point. Are there any other ways a line and a plane can interact in 3D? Draw another plane here. Is it possible for a line to not touch a plane? Remember, planes extend in all directions infinitely, just like a line does. I'm just drawing a small rectangular piece of it. Well, if you think about it, what if that line is parallel to that plane? It's either above or below. So I'm going to sort of draw a little shadow on the plane. Let's pretend that there's a shadow of that line, just to indicate that that line is directly above the plane, right? You see that? You sort of see what I'm drawing? I know it's hard to draw in 3D on a 2D surface, but let's pretend that that line is directly above the plane. Those will never meet as long as they're parallel. How many solutions does this have? 0. So this is going to be a similar case to two lines that are parallel and never meet, right? So this is a possibility for lines and planes as well. There is a third option, and maybe you've figured out what it is already, but what happens if the line and the plane are parallel, but that line is actually on the plane? How many solutions do we have? Well, if you think about it, every point on that line is a solution, is a point of intersection. So we would say in this case that there is an infinite number of solutions. Now there's only 3 cases here. It's actually simpler than lines because there are only 3 different ways these two things can interact, right? Either there's one solution, goes through, 0 solutions, they're parallel and not touching, or infinite where they're parallel and are on top of each other. We call these, by the way, when the lines are sort of on the plane, we call that coplanar. So the plane and the line are coplanar because they all exist on the same plane. So I'm actually going to write that down. Coplanar. Okay, actually, and I'll write this one down as parallel as well. Okay? So now we're going to learn how to algebraically determine the solutions to these systems and figure out which case it's in. So, question 5. We're given the line, I'll call it L1, we're given the line in vector form, correct? Whenever we want to do algebra, we should always write it in parametric form. So 3 plus s, y is equal to 1 minus 4s, z is equal to 2 minus 8s. And we're given our plane, I'll call that pi 1, because we usually call planes pi. We're given our plane in Cartesian form. 4x plus 2y minus z minus 8 equals 0. Okay, how do we determine the point of intersection of these two things? Well, you should notice right away that there's some things in common in these two equations. We have an x, we have a y, we have a z in both equations. What can we do? Well, your gut hopefully is telling you just to plug these 3 equations into that equation and see what we get. If we do that, actually let's just do that first. So if we do that, we're going to get 4x, which is 3 plus s, plus 2y, which is 1 minus 4s, minus z, which is 2 plus 8s, minus 8 equals 0. Now, if you look at here what we have one equation. I can call it equation 1 if I want. But how many unknowns are there? Well, there's only one unknown thing in this equation. So when we have one equation and one unknown, we're able to solve it. This is a linear equation that we can solve. So let's do that super fast. So 12 plus 4s plus 2 minus 8s minus 2 plus 8s minus 8 equals 0. nicely. These just end up canceling each other out. For the numbers, we have 12 plus 2, which is 14, minus 2, so these 2's actually end up canceling out. 12 minus 8, which is 4. So we end up with 4s equals negative 4. 4s equals negative 4. Stuff won't always cancel out like that. It just happened to in this equation. So we have s equals negative 1. So this tells us that the s value that generates that point has got to be negative 1. So now we can just plug that back into our equation. And L1 was the equation that, or the equations that had the s in them. So we can just plug that in to see what we get. So s equals negative 1. So let's just plug that in for x. It's going to be 2. Y, it's going to be 5. And z is going to be 10. And if we look on the answers, that is the correct answer. So clearly, plugging in s works. There's no issues. It just directly plugs in. We get a solution. So clearly, this is the first case where we have one solution. And that is the point. That is the solution. So I'm just going to put a therefore statement. It's always good at the end to put a therefore statement. Therefore, the POI is 2, 5, 10. Okay? The point of intersection or solution. Now, we can look at the next one. Let's do that. Let's try the same thing. I actually want you to pause the video here, try to solve for it, and see what happens. So when you do this, hopefully you got this answer, that you get something like this. 0t equals 3. So is there a solution to this problem? No value for t is going to give you an answer, right? There's no value for t you can plug in to give you 3. So, therefore, it's quite clear that there's no solution. Correct? So, that's pretty obviously which case it is, because there is only one case that has no solution, and that's if the plane and the line are parallel to each other. Now, I just want to put out there, is there another way to find out if a line and a plane are parallel to each other? There's actually a few ways to do it, but there is one way that's pretty nice, that's a good quick check to see if the line and the plane are parallel to each other. And that way is to look at the normal of the plane. Remember, a normal of a plane comes straight up from the plane, right, at a 90-degree angle. What do you notice about the angle that normal is going to make with the line? Well, you should realize that's also going to be 90 degrees. So, in other words, if the normal is perpendicular to the line, then the line must be parallel to the plane. How can you check if two things are perpendicular to each other? You can use the dot product. So very quickly, if we do the dot product of the direction vector of the line and the normal of our plane, and we know the normal of the plane is just the coefficient. So in this case, it's 2, negative 5, 1. Our direction vector, we'll call that m, of the line is 1, 2, 8. If we do n dot m, we should get 0 if they're perpendicular. So let's do that. So it's 2 times 1 is 2. Negative 5 times 2 is negative 10. And 8 times 1 is 8, which does equal 0. That actually tells us right away, therefore, the line and the plane are parallel. Right? So that's a very quick way to check if the line and the plane are parallel. You notice that doesn't actually tell you if we're in this case here or this case here, right? Because in both cases the line is parallel. So you will need to sort of do an extra check, and the extra check is pretty easy. If you wanted to check based on this, whether it's on the line, you could easily just plug in the point 229 into this equation, and it should give you 0. If it doesn't give you 0, then that point is not on the line. Okay? But that's just a quick way to check to see if a line is parallel to a plane, if you're given the Cartesian form. So 7 is a similar thing. I want you to try 7 yourself. Okay, I'll show it to you now. I want you to try 7 yourself. pause the video here, try it yourself, unpause when you think you have a solution. So if you do this process, you should get 0 equals 0s or something like that. This tells us that the solution to this is that s can be an element of real numbers, right? Because any value of s will make this equation true. When this is true, we know it has to be this case here, where the line and the plane are coplanar. The line is on the plane, because any point on that line is a solution to the problem. So, and you could also check, you could do the same thing we did in the last one. We can dot product the normal of the plane and the line, and that should be 0 as well. It should tell us that they're perpendicular to each other as just a quick check. But this case is different because the line is on the plane. So again, the way you could check that, if you plug in the point on this line that's given, 3, -2, 1, into this equation, it should equal 0. And that tells us that that point is on that line. And therefore, the line is on the plane.